Okay, let's do an example of finding the least common multiple of 21 and 14. You have two different ways we can do this. We can do it using the listing multiples method, or we can do it with a Venn diagram. So, listing multiples, first we would start off with 21. So remember, multiples are the numbers that 21 can make through multiplication. So the first number of any multiple list will wind up being the number, because 21 times 1 is 21. The next is 42, because that's 21 times 2. But if you don't know your multiplication tables or facts very well, it's just going to be a pattern of adding 21 every time. So 21 times 3 is going to wind up being 63. 21 times 4 is going to wind up being 84. Then let's make a list for 14. So again, the first multiple will be itself, 14. And then either using multiplication, like 14 times 2 and so forth, or just following the pattern of adding 14, the multiples will become 28, and then 42, and then 56, and then 70, and then 84. So if we look on this list, I see two numbers that are matching, 42 and 84. So both 42 and 84 are both considered common multiples because they are multiples that are in common in both lists. But the 42 is the least common multiple. So the least common multiple, or LCM, is equal to 42. So that means I really could have stopped as soon as I saw 42 is the same. I didn't have to keep going 84, but I just wanted to show you the difference between a common multiple and a least common multiple. Now, the other method that you can use is you can also use a Venn diagram. Now, we have worked with Venn diagrams already when we were doing greatest common factor, or GCF. So this is not a new concept, making this Venn diagram, because it's set up the same exact way as when we were doing GCF. So we're going to have the two overlapping circles of the Venn diagram. The one circle represents the number 21, the other one represents the number 14. So we're going to do a factor tree to find out what makes 21 using prime factors. So that's 7 times 3, and those are both prime, so we can put the circles around them to let us know that those are dead ends where the prime numbers are. And 14 is 2 and 7. So I have prime factors right there. So the middle part of the Venn diagram is always where the GCF, or the greatest common factor, is found. And that's found by looking for the numbers that are in common between the two trees. And if you see, we have a pair of 7s, and I cross them off so I don't accidentally use them again. So I write 1 7 in for the pair of 7s that's in common. Now, this number right here can be found a couple different ways. We can ask ourselves, 7 times what equals the 21? Or we can ask ourselves, 21 divided by 7 equals what? Or we could just look over at this tree and say, okay, what was not used? Oh, that 3 was not used. Now, if there was more than one number not used over here, you would multiply those numbers together to figure out what that number is. But 7 times 3 is 21. The same way that 7 times 2 is 14. Now, with LCM, we are simply going to take the Venn diagram and multiply the three numbers together. So we're going to do 3 times 7 times 2. So 3 times 7 is 21, and 21 times 2 is equal to 42, which is the same LCM that we got right there. So you may be thinking to yourself, why not just do the list all the time instead of doing the Venn diagram, because it seemed like it took longer to do that? Well, in this case it did, but once the list becomes a little more complicated, like larger numbers or just numbers that don't match right away, the list is going to take longer to find your matches, and the Venn diagram actually starts to become easier to work with. So it's good to know both ways. So hopefully that helped you out.